Our essential question for this video is, what shortcuts can I use to prove that two triangles are similar? What shortcuts can I use to prove that two triangles are similar? We've already covered, class, 3 ways to prove that two shapes are similar. We talked about looking for COD and scale factor. We talked about comparing all of the corresponding sides and corresponding angles. And we also showed that we can use transformations to prove that two things are similar. Well, triangles, fortunately, have some shortcuts to them. There are ways that we can prove that two triangles are similar without having to check every single side and every single angle. And the first one we're looking at is what's called angle-angle similarity. So here's our theorem. If two angles of one triangle are congruent to two angles of another triangle, then the triangles must be similar. Remember our shortcuts for proving that two triangles are congruent. If you want to make a little note up here on that, we had side, side, side congruence. We had side, angle, side. We had angle, side, angle. And we had, for right triangles, hypotenuse, leg. Well, similarity has shortcuts as well. And the first one is angle-angle similarity. Let's see how this works. Take a look at these two triangles. Okay, let's label the vertices so we can make sense of this. Let's call this G, H, I. I don't know, let's do J, K, L. Now we see these triangles are not in the same orientation. They're either rotated or reflected. I'm not sure which one. It doesn't really matter. Now here's what I want to show you. Here's the two things we're going to look at here. Since, let's take a look at a sense. Since angle G is congruent to angle L. In fact, let's do a circle around them like we've done before. G and L are both 30 degrees. We know those are congruent. And angle I is congruent to angle J. And let's double circle those. I is 45 and J is 45. Okay, so we've got two sets of angles that are congruent. If we know that we've got two angles of one triangle that are congruent to two angles of another triangle, then we can write this. Then we know that triangle, and let's put these in, we'll just put them in order. I'm gonna do this way. I'm gonna go with a single circle first, G. I'll go for double circle next, I, and then I'll go for no circle, H is similar to triangle. Now I'm gonna go with single circle again, L, double circle, J, and then no circle, K. Now remember, the order of these letters matters. The letter from the first position has to correspond to the letter from the angle from the first position of the second triangle, and we have used our circles to do that. Now I could say this all different ways, class. I could rearrange these letters as long as I rearrange these letters so that first position lines up with first position. Second position angle matches up with the second position angle. So in this case I chose to put them in this order. And this is how easy it is to prove that two triangles are similar. If we know that we've got two angles congruent in each of those, then we know they are similar in every way. Okay, so there's our first part. One more thing we note here. We already talked about this, that G corresponds to L, J corresponds to I, H corresponds to K. One more thing I want you to make a little note on the bottom of this. I want you to remember, put a reminder to yourself. The interior angles of a triangle always add to 180 degrees, so the third angle will also be congruent. That means, technically, we know that H and K are also congruent to each other, but we don't have to call it angle, 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 because two angles are enough to prove similarity. The third angle we automatically know has to be congruent, because all three of these angles have to add up to 180. All three of these have to add up to 180, which means H and K will be the same angle measure. Alright, let's put this to work, see how this works. Here's our first question. Are these two triangles similar? This can be a very deceptive question. Let's label the vertices just so we can match them up or talk about them together. Let's say this is A, B, C. I don't care what the letters are down here. They don't have to match up. We'll just put D, E, and F. Alright, now I can already see that angle B matches angle E. So I've got one congruent angle, but I don't have another one. 74 does not match 54. And so there's a tendency for us to say, no, they are not similar. But you don't want to jump to that conclusion, because we need to find out what the final angle measure is to make sure we don't have a second congruent angle. So let's find the measure of angle A. The measure of angle A is going to be equal to 180 minus 52 minus 54. Those are the two angles I know in that triangle. Let me fix this real quick. Make sure that looks like a 5 for you guys. Put that in your calculator. 180 minus 52 minus 54. You're going to get 74 degrees. And now look what happens, class. When we label this one as 74 degrees, now you see that angle A is congruent to angle D. So now we do have similarity. Now, do I have to check the other angle, angle F? I don't even need to check it. I can do it, but I don't have to do it. I've already got two angles from triangle ABC that are congruent to two angles of DEF, and therefore I know that these two triangles are similar. So I can actually write my similarity right now. So I can write on here, since angle B is congruent to angle E and angle A is congruent to angle D, then triangle ABC, let's make sure we match up our angles correctly. A goes together with D, so D has to go first. Then I've got B, which is I'm gonna go ahead and do single first. So B and E, those correspond. So I had this right. A goes to D. I apologize. And then we've got our next letter is B. B is a single mark. That goes to E. And then C, our third position, goes to the one that's not marked, which is F. So we know that these two triangles are similar. And you could write as your proof, you could say by the AA theorem. So don't forget, when you get two triangles and you only see two angles and you see those don't match up, never assume they're not similar. Always figure out at least one of the third angles and make sure that that also doesn't match. If this was 73, then 54 doesn't match that one and 73 doesn't match that one. There's no way that we could have two angles that are congruent. All right, next one, last one. How about this one? Are these two triangles similar? Well, let's take a look. I'm going to label these. It's interesting. These are two triangles. They're touching at one vertex. I don't know if they're similar yet. Let's figure it out. Let's label this. I'm going to say this is A. Actually, you know what? Let's change that a bit. Let's say this is A. I'm going to call this B. Let's call the middle point C. And then I'll call this D and this E. Again, you can label the vertices any way you want. All right, now let's take a look. We've got one angle that we know is congruent. We've got angle E and angle B. Those two angles are congruent. We're going to need another congruent angle to verify these are similar. And the good news is, you guys learned this last year, vertical angles are congruent. This angle right here and this angle right here have to be the same size because they're made by two intersecting line segments. So now look what we've got. I don't know what the angle measure is, but I do know it's congruent. And even though I don't know the angle measure, as long as I know it's congruent, I can prove that these two triangles are similar. We've got angle C, these two angles, and we've got these two angles. So here's what I know. Since angle E is congruent to angle B, and I'm almost going to do this. I'm going to put and angle. Now I can't say angle C because angle C, I don't know which angle I'm talking about. So I'm going to call this one ECD. Angle ECD is congruent to angle, and I'll call this one ACB. And I'm going to put in note why I know that. Vertical angles. So I can justify those must be congruent by vertical angles. Now look, I've got two pairs, so then triangle, and let's name the first triangle, I'll name it ABC, is similar to triangle. Let's find out what matches. A matches up with D. It's the one angle that we didn't mark, so A goes together with D. Now let's take a look at B. B is a single circle. That goes together with E. And then you can see that angle C from the first triangle matches up with angle C of the second triangle. And we're going to say we know this by the angle-angle theorem. So we just were able to prove that these two triangles are also congruent. In class, if we know, also similar, and if they're similar, then I know that the sides are proportional, so I could actually find missing side measures if they gave some to me. Okay, so the last thing it's going to ask is which triangle side corresponds to AC? Well, let's take a look. Look at our similarity statement. A and C are the first position and the third position. That means it must correspond to DC. So you can write on here as your answer, based on what I wrote in my similarity statement, AC corresponds to, take a look again, first and last position to DC. So this side right here, AC, actually corresponds to this side right here. You'd think it'd be the two top ones, but it's not. It's this one and this one. And we know that based on our similarity statement. We've learned that in a previous video. So there are 2 times we've proven that 2 triangles are similar. Class, you will have some situations where you check them out and you find out you cannot prove they are similar. But in this case, I've got 2 examples that do turn out to be similar.